ketones can basically reduce this oxidative stress, which is the end goal of antioxidants. And so within the past probably 5 or so years, there's really been an explosion in the amount of interest in the research in this space. And paper after paper is being published looking at this role of ketones as signaling molecules. So they're directly influencing functional effects within the cell. You can take antioxidants. You know, people think of some of our food sources as being high in antioxidants, but it's important to know that we also make our own antioxidants. So our cells, our DNA can encode genes that then basically have those same effects as well. Beta-hydroxybutyrate is what we call a histone deacetylase inhibitor. And that's a big word, but basically it means that it actually travels to the DNA and binds there and allows certain genes to be open so that those genes are expressed, so actively influencing the expression of those genes. And what we've seen in some of these studies are that a lot of the effects or some of these beneficial effects that we already know of ketosis in general. So for example, they increase the expression of our own body's antioxidant genes and things like that. Ketones can kind of play into this scenario in a number of different ways. So you can have ketones that are in the blood, and then they get taken into the cell through transporters, and then they end up in the cell, or they can bind to receptors on the cell membrane. They begin to communicate with other proteins within the cell and elicit these specific effects, or they even go and bind directly to the DNA and elicit effects that way. So if you think about it, we have to constantly take in this environmental information. So there are signals to us coming in from the environment in terms of the nutrients that you are able to consume at any point in time tell your body a lot of information about the world. Are you in a state where you have ample access to nutrients or not? That's going to affect how your tissue treats itself and how it prepares, right? Pathogens in the environment that you may need to respond to, stressors or chemicals like carcinogens. And again, for our body to mount these appropriate responses or defenses, again, we need these chemical messengers. It's like the communication system within the body. And it's very complex. So cells are tiny, right? They're microscopic, but they're very complex in both their composition and their behavior. And they really require these extremely advanced levels of communication. Studies in cell culture have demonstrated this basically, and essentially what cell culture has to use is just the application of ketones that are added to the petri dish. So it would be the kind of primitive analog to an actual organism taking an exogenous ketone. Yeah, so that's what has been shown in like preclinical work. So it was shown through a signaling mechanism. Ketones actually go to the DNA at these genes where those antioxidants are encoded and basically increase our body's own defense mechanisms against oxidative stress by increasing the expression of those genes.